Glass electrode. Glass electrode is an ion selective electrode made of a doped glass membrane sensitive to a specific ion. It consists of low melting glass having high electrical conductivity. It's a universally employed electrode for pH measurement. For pH measurement, H plus ion selective glass electrode is used. When two solutions of different pH values are separated by a thin glass membrane, there develops a potential difference between the two surfaces of the membrane. This potential difference developed is proportional to the difference in pH value. This is the principle in a glass electrode. The glass membrane functions as an ion selective resin, and an equilibrium is set up between the Na plus ions of glass and H plus ions in solution. So in the electrode reaction, the H plus ions exchanges with the Na plus ions in the glass membrane. The glass electrode assembly consists of a long glass tube with a thin glass bulb filled with 0.1 molar HCl. The inner surface of the glass is in contact with a silver electrode coated with silver chloride, or simply a platinum contact electrode. HCl in the bulb furnishes a constant H plus ion concentration. Then, in order to measure the pH of a test solution, this glass electrode it is immersed in the test solution, so that the outer surface of the glass bulb will be in contact with the test solution whose pH is to be determined. And the electrode representation is silver in contact with silver chloride. It is in contact with 0.1 molar HCl. Then glass membrane in contact with H plus ions of unknown concentration. Or just it can also be represented as PT, that is platinum, in contact with 0.1 molar H plus, in contact with glass membrane, contact with H plus ions of unknown concentration. The enhanced equation for this electrode at 25 degrees Celsius is Eg is equal to E naught G minus 0.0591 log 1 by H plus ion concentration. Log 1 by H plus ion concentration is minus log H plus concentration. Therefore, finally the equation comes to Eg equal to E naught G minus 0.0591 pH. And E naught G, that is the standard electrode potential of the glass electrode, is 0.6 or 0.5 depending on the variety of glass. The advantages of glass electrode: it can be used even in strong oxidizing solutions. It can be used in presence of metallic ions, poisons, etc. because the electrode will not be poisoned easily. It's simple to operate and hence extensively used in different laboratories in chemical, industrial, agricultural and biological laboratories. The glass electrode can be used in solutions of pH values ranging from 0 to 9. It has a limitation also. The glass membrane, though very thin, has a very high resistance of the order of 10 to 100 million ohms. Hence, ordinary potentiometers cannot be used. Special electronic potentiometers have to be used for measuring the potential of a glass electrode. Measurement of pH using glass electrode. In order to measure the pH using glass electrode, the glass electrode is to be coupled with a saturated calomel electrode. When the glass electrode is coupled with a saturated calomel electrode, glass electrode will be acting as the cathode because its electrode potential is higher than that of saturated calomel electrode. So the cell representation will be calomel on the left side and on the right side glass electrode. So Hg in contact with Hg2Cl2 in contact with saturated potassium chloride solution, then salt bridge, and glass electrode representation: H plus with unknown concentration, glass membrane, H plus with 0.1 molar concentration in contact with platinum or even AgClAg, so that the EMF of the cell measured will be E cell equal to E right minus E left. E cell equal to E right means that of the glass electrode, that is E naught G minus 0.0591 pH minus 0.2422. Now equation 2 can be converted into in equation 3 by grouping the constant values E naught G minus 0.2422 together minus 0.0591 pH. This equation is of the form of a straight line. That is, when we plot E cell along the y-axis, EMF of the cell along the y-axis and pH along the x-axis, if we plot a straight line graph will be obtained with a negative slope, that is m is equal to minus 0.0591, and the intercept of this graph will be E naught g minus 0.2422. So generally we can represent this equation as, instead of E cell, it can be E equal to A stands for E naught g minus 0.2422, the intercept, plus B into B stands for the slope, that is minus 0.0591 into pH. And the constants A and B or C and M can be calculated or determined by calibrating the pH meter with two buffer solutions of non-pH. Usually pH 4 buffer and pH 9.2 buffer solutions are used for calibrating the pH meter. And corresponding to pH 4 and pH 9.2, we will get EMF values, that is corresponding to pH buffer, buffer of pH 4, the EMF let it be E1, and corresponding to pH equal to 9.2 buffer, let the EMF be E2. Using equation 6 and 7, we can solve the equations for the values of A and B, and these values of A and B can be used for the determination of pH of any solution. So an unknown solution is used for finding the EMF of that particular cell. We are using an unknown solution or a solution of unknown pH. Corresponding E cell is noted, and substituting the values of A and B in equation 8, we can calculate the value of unknown pH. This is how we can measure the pH using a glass electrode coupled with a calomel electrode. Now this electrode assembly can be of the combined type, that is glass electrode combined with reference electrode in a single bulb, or double bulb, that is depending on the instrument. Thank you.